Hey pre-calc, in this video we'll be looking at aim number 105, how do we differentiate non-functions using implicit differentiation. So all the differentiation techniques that we've learned so far have been applied to functions. But we learned a few curves this year that were not functions. So how do we differentiate those curves? That's where we're going to use the technique of implicit differentiation. So to start, let's look graphically at a non-function. So sketch the circle, x squared plus y squared equals 25. So it's already been drawn out for us, a circle of radius 5. We want to approximate the derivative at 3 different x values. So the way we approximated the derivative was drawing in the tangent line at each point and approximating its slope. So at x equals 0, we'll draw in the tangent line, but what I notice is we have 2 different points when x equals 0. Now it just so happens they both have the same slope of their tangent lines, and in this case both slopes are 0. So whether we're at 0, 5 or 0, negative 5, the derivative of x squared plus y squared equals 25 at x equals 0 is going to be 0. The next point, x equals 5, so that's right here. We draw in the tangent line, and that's a vertical tangent line, so the derivative would be undefined. And then lastly, at x equals 4, so we have the point there, and we have the point there. Now what we notice is we have 2 different slopes, one positive and one negative. So at the point 4, 3, up here, the slope appears to be about negative 1, and at the point 4, negative 3, the slope looks to be positive 1. So what that tells me is the point that we're at on the curve matters. Not just the x value, but the actual point. What that also tells me is that the derivative of an implicitly defined curve is going to be in terms of both x and y. That's the only way we can get these two terms to be different, because they both have the same x value. So let's look more at implicit differentiation. So implicit differentiation is the method used for finding derivatives of non-functions or functions where y cannot be expressed explicitly in terms of x. So basically, even if we do have a function, but it would be really difficult to isolate the y variable, then we'll just use implicit differentiation. It's going to be quicker. Now, implicit differentiation is nothing more than a special case of the well-known chain rule for derivatives. Okay, so that's what you're going to have to wrap your head around as we go through the video. It is important to note that the derivative expression for explicit differentiation involves x only, so this means for a function, explicit y equals or f of x equals, while the derivative expression for implicit differentiation may involve both x and y, as I mentioned when x equals 4 in that last case we were looking at graphically. Okay, so let's jump into a few problems to wrap our head around the technique of implicit differentiation. So find dy dx for x squared plus y squared equals 25. So when we're doing implicit differentiation, the first thing you have to understand is that y is a function of x. So just like y equals 2x plus 3 or y equals x squared, a y we're treating as a function of x. So now we're going to differentiate. We're differentiating with respect to x. So the derivative of x squared with respect to x, that's just 2x. Same way we've been differentiating before with the power rule. Now, y squared. We're going to treat this as a composition of functions. Y is the inner function, squared is the outer function. So the derivative of the outer function, bring the 2 down, y to the first, times the derivative of the inside. Now I know most of you might be thinking, well, the derivative would just be 1. But we have to remember, y is a function of x. So we're differentiating y with respect to x. What is that going to be? Well, that's going to be dy dx. So times dy dx, and the derivative of 25 is 0. Okay, so let's run this back real quick. So y squared, derivative of that, derivative of the outer function is 2y to the first. Then we're going to differentiate the inner function, differentiating y. But again, y is a function of x, so the derivative of y with respect to x is dy dx. And we need this piece here because that's what we're solving for. So now solving, we'd have dy dx 2y equals negative 2x, and dy dx equals negative x over y. So what we notice is the derivative is in terms of both x and y, and we had to do a little bit of solving to get dy dx by itself. Right? So if you can wrap your head around this idea, then the rest of implicit differentiation is just seeing problems expressed in different ways and doing the same thing. Find the derivative of the curve x squared plus 9y squared equals 27. Okay, so again, derivative of x squared with respect to x is 2x. Derivative of 9y squared, that's going to be 18y. Derivative of the outer function inside stays the same, times the derivative of the inner function, which is dy dx, equals 0. So 18y dy dx equals negative 2x, and dy dx is equal to negative x over 9y. Now, just to point something out, because you might look and say, why are we treating the derivative of 9y squared as a chain rule and not x squared? We can treat x squared as a chain rule. So, put parentheses like that. Derivative of the outer function inside stays the same, times the derivative of the inner function. Well, the derivative of x with respect to x, well, technically it's dx dx, which would just become 1. That's why we don't write it out. But just in case you were wondering, that's what it would look like if we apply the chain rule to everything here. So now continuing, write the equation of all horizontal tangents. Well, a horizontal tangent means the slope is equal to 0. So I'm looking for all points where dy dx is equal to 0. So negative x over 9y equals 0. So when does that happen? That happens when x equals 0. But I want the equation of the horizontal tangent lines. Those are y equals equations, and I need y equals values. So I have to go back into the original expression here and plug in 0 for x. So we get 9y squared equals 27. Y squared equals 3. So y equals plus or minus the square root of 3. There's the equations of the horizontal tangent lines. Find the equations of all vertical tangents. Okay, so vertical tangent lines, that means the slope is undefined. So we're looking for when dy dx is undefined. So that'll happen when the denominator is equal to 0. So we're looking for where 9y equals 0. So y equals 0. Now again, we have more work to do because we need the equation of the vertical tangent, and vertical lines have x equals equations. So x squared equals 27. So x equals plus or minus square root of 27, 3 rad 3. So we have the equation of 2 horizontal tangent lines, equation of 2 vertical tangent lines. Okay, on to the next example. X squared plus x times y plus y squared equals 7. So we are increasing the difficulty a little bit with this middle term. Okay, so find dy dx. So the derivative of x squared with respect to x, that's 2x. The derivative of x times y is going to require a product rule. So the derivative of the first is the same, derivative of the second. So x times, well, the derivative of y with respect to x is dy dx, plus, second stays the same, times the derivative of the first, so y times the derivative of x, which is just 1, plus the derivative of y squared. We've done this a few times now, so 2y dy dx, that's by the chain rule. Derivative of 7 is 0. So now what we notice is we have two terms with dy dx in them. So we're going to move all the terms without to the other side. So x dy dx plus 2y dy dx equals negative 2x minus y. And then we're going to factor out a dy dx. And I'm going to divide 2 at the same step. So that's going to be over x plus 2y. So there is the expression for the derivative of y with respect to x for this implicitly defined equation. Write the equation of the tangent lines at x equals 1. Okay, so what are the two things we need to write the equation of a tangent line? We need a point and we need a slope. So let's start with the point. We'll go into the original and plug x equals 1 in. So we get 1 plus y squared equals 7. So rearranging that a little bit, y squared plus y minus 6 equals 0. So y plus 3, y minus 2 equals 0. Y equals negative 3, y equals 2. So that means we have 2 points on this curve when x equals 1. So the first point is 1, negative 3, and the other point is 1, 2. So at each point we need to find the slope separately because it could be different. So at the point 1, negative 3, the slope is going to be negative 2 plus 3, so that's 1. And then 1 minus 6 is negative 5. So we had 1 over negative 5, so negative 1/5. So the equation of that tangent line, y plus 3, equals negative 1/5, x minus 1. And then we need to find the slope at the other point. So dy dx is equal to, so we have negative 2 minus 2, so negative 4. And then over 5, so negative 4 over 5. So y minus 2 equals negative 4/5, x minus 1. Okay. Last example. 2x squared minus 2xy plus y squared equals 4. So find dy dx. Notice we have another product rule here in the middle. So the derivative of 2x squared is 4x. Now, you have to be careful here with this minus sign. This is the mistake that most students make. Either distribute it as you go along and treat it as negative 2x, the function, or put a negative and then put parentheses over the product rule you're about to expand. So I'll do it that way. So first stays the same. Derivative of the second, derivative of y is dy dx, plus second times the derivative of the first is going to be 2y, plus, now using the chain rule, 2y dy dx equals 0. So we can distribute the negative to both terms here and move all of the terms without dy dx to the other side. So we have negative 2x dy dx plus 2y dy dx equals 2y minus 4x. Right, we have negative 2y, so that becomes positive. 4x becomes negative. And we get dy dx equals, so we're factoring out the dy dx, and I'm dividing the same step, 2y minus 4x over 2y minus 2x. So we could simplify that to y minus 2x over y minus x. Makes evaluating the derivative a little bit simpler. Write the equation of the tangent lines at x equals 0. So again, we need a point and a slope. So we'll plug 0 in for x. So that's just going to be y squared equals 4. So y equals plus or minus 2. So we have 0, 2, and 0, negative 2 as our points. So what is the slope at 0, 2? That's going to be 2 over 2, so that's 1. So we get y minus 2 equals x. And then 0, negative 2, the slope, dy dx, is equal to negative 2 over negative 2, so 1 as well. So y plus 2 equals x. And then find the equations of all vertical and horizontal tangents. I'll leave that for you to try on your own. Remember, vertical, the slope is undefined. Horizontal, the slope is 0. And then you have to go and find the equations. All right? Write down any questions that you have about implicit differentiation. We'll work through more problems in class. Take the quiz that goes along with this video. And we'll see everyone in class. Enjoy the rest of your day.